in whiteboard. Hello, everyone. Nice to see you all. Welcome, welcome. Just getting my screen set up here. All right, all right. Got my screens configured. Welcome to SQL. Thanks for being here. I'm Thomas. Be teaching the SQL module. I've taught this, I think this is the 8th time, which I think might be the most of any of the DSI instructors at this point. Been here since the very first pilot. It was 2022 now, so it's great. This is the first time with the SGS PhD program. I'm really excited. It's really nice to have a different audience. I look forward to sort of your guys' take on these things, content and such. So do a little bit of an introduction here just about course and also some of the tools that I'm going to use throughout. One obviously being the Etherpad. I think most people have made their way to it. So I see about 50 people in here. I'm going to use this throughout, and it's just a good way for me to kind of keep time on the topics, give a little bit of content beforehand, questions and objectives, things like that. It's also space for if question time from you all starts to become a little bit too slow, which certainly can happen. There's space to add questions to this so I can respond to later, just kind of a parking lot for that. Just reminders for breaks and things like that as well, which is always useful when you're learning, right? We'll also, obviously, we'll have some slides to go through. Today is always it's the most theory heavy of the days. We won't do any coding today. But we will for the remaining 4 sessions after that. So I think most people probably, I did see great response on my pre-course survey. Thanks for doing that. I appreciate that always. It's really nice to see where people are coming from, especially technically. It seems like a lot of people have some R, a little bit of Python experience. We won't touch too much on that, but it's great to know that's where people were at. If this is the first time with any of that, also welcome. Don't worry, you won't be the first to come in having not done any data related things in the past. So I think there's good pacing for you as well. So with that, let me hop to slides here. Just do a little bit of welcome. Have both learning support, Niaz and Kelly, with me today so they can introduce themselves. And well, so then we'll hop into some of that theory related stuff. So I'm Thomas. I always kind of forget to introduce myself. I'm here in Hamilton. I think a fair number of you being U of T, likely nearby. Sometimes for the rest of the cohorts, they're all over the place. So nice to have people possibly nearby. My first SQL job was out of my undergrad quite a while ago at this point. I since then have done a lot of different data work here. I worked as what really used to be called a data analyst, and I was in the US doing healthcare work until I moved to Canada in 2018. US healthcare data is pretty challenging, but it's easy to see that the impact of good queries. I also was pretty naive about how things work, and I can say I was pretty lucky that I didn't break things. I was also in an environment that didn't set me up for success, didn't have a lot of control in that regard. I always think environments nowadays are a lot more structured, a little bit less what we used to call cowboy coding, free from source control and rules. So I was fortunate not to do anything too bad. In Canada, I've worked as a data engineer at Plan Canada, the charity. I managed their CRM data warehouse backend. That was a very SQL heavy role. And I was the only data engineer, being that Plan's pretty small organization. After that, I went back to U of T to do my Master of Information. I was really thinking at the time that I wanted to do less SQL work and more R and Python work. This was like about 2020 before 2019. I was kind of feeling like that SQL was making its way out, but I think I was really wrong on that. SQL is definitely still very present in the data science pipeline, and there's still people who practice pure SQL, and there's the vast majority of people who are using SQL alongside other programming languages for retrieval. I call myself nowadays a reluctant data scientist. So do we even need this model? I do AI governance and ethics implementation at the software company Dataiku. And before that, I was at Thomson Reuters doing similar work for their AI governance team. And this is my Samoyed Alto. She's grown up, as these slides have too, so I have to always keep changing the. I need a more wintry one. All right, Kelly, go ahead. Oh, Kelly, I've spelled your name wrong here. I can't believe it. It's even worse. Terrible. All right, Kelly, please go ahead.
All right. Okay, so hello again. I'm Kelly. All of you already know me because I was your learning support for the last module, and I'll be for this one and next one too. So you're very privileged and very lucky. Okay, so I actually went to grad school with Thomas. We were grad school buddies. And from there, I met Rohan as well. He was kind of my supervisor, mentor for a lot of projects. And I am interested in the ethical dimensions of NLP and LLMs. I'm currently applying for a PhD again in the iSchool, Faculty of Information in U of T, to pursue further research. And I worked in the industry as a data engineer, and where I work with Python daily. And I would say SQL weekly, not as much, but I'm good enough. And I actually had a bachelor degree in fine arts. I wanted to be an art teacher since I was a kid, and hopefully one day I can still be one. And my hobbies are reading, I love plants, and I love bubble teas. I'm from Taiwan. So if you need any bubble tea intels, I'm the right person to get it. Okay. Please take away. Yes.
Hi, everyone. My name is Niaz. I'm a software engineer. Actually, I have 15 years experience in database architecture, database development, and administration. Currently, I work as a CTO for JetSEO startup, and I work for 3 cohorts with DSI as learning support for SQL course. I'm really interested in this field and passionate about optimizing database performance. And I hope we can have a great SQL course together. That's it. Finish. Thank you.
I really am excited to have Kelly and Niaz. Niaz been with me now, like she said, three times, and Kelly, we were together in grad school, and I hadn't seen her for a fair bit, so it's really exciting for me. I hope you guys will enjoy having them. They always are super great learning support. Okay, let me talk a little bit about the course content here. So we'll talk about data modeling, data structures, schemas, basic data management. We won't get to normal forms, but the content is going to be on GitHub. There's just not quite enough time. They took away the 6th class for the PhDs, so we only have 5. We'll do basic SQL syntax and some more advanced SQL syntax and techniques as we go along. Everything kind of builds on the previous. You'll find with SQL, the syntax is not overly challenging, and there aren't like thousands of keywords. There are like maybe 100. So it's more about like the way you think about things. And so that's why we'll talk more today about that. And then you kind of get used to how to use the keywords themselves. And when we do that, that'll be through the live coding. We'll talk about importing and exporting data to and from SQL. There's also some content that I don't think we'll get to, maybe in the 5th, depending on timing, on how to use R and or Python for together with SQL. But I'll tell you, it's fairly straightforward in terms of making those connections. I'm going to talk a little bit about SQL's relationship in the machine learning pipeline, as that's certainly some people's interests. Here's some of the tools we'll use. Obviously, well, first, as I've sent out in an email, if you haven't checked your email, it'll be needed for our Tuesday session. We'll use DB Browser for SQLite. I'll talk why I've picked SQLite throughout today's lecture, but it's super easy to install. There's instructions. If you have trouble with it, reach out to course support or come to office hours. You definitely need to have it installed by Tuesday, or it will make it very challenging for you. We have the Etherpad, as I've said, visit and complete this. There's a little prompt at the start for each session. It's just nice for me to get to know everybody. I've linked the SQLite documentation. If you get something super specific, maybe you'll go there. Maybe I'll go there once or twice. I've linked Draw.io and Lucid. This is for both your assignments. I'll talk about the assignments towards the end of today. These are our tools to help you do kind of data modeling, just mock-up drawings. I like Draw.io better than Lucid because it doesn't require a sign-up. It's open source, but you can use whatever you prefer. And we'll use CodeShare as well. CodeShare is just, I don't know if you guys used it for Shell. Usually you use it in Python. Python usually comes before SQL, but it's not this time. CodeShare is just like a paste, like a copy-paste clipboard, essentially, where as I type things, sometimes I type just a little bit faster than you perhaps. You're still working out something, but I'm moving on. I'll put the code that we've just written together in the CodeShare so that you can keep caught up. But also say I save all of the in-class code to GitHub. Not the CodeShare is not the official code or anything like that. It's just sort of our like facilitating, clipboard. So do remember to just actually go to the GitHub and grab the in-class code if yours is different. And Mentimeter, we'll just do some small in-class quizzes. They're all ungraded. They're just a couple of questions for just tracking learning comprehension. Let's talk about the GitHub repo. These are all standardized, so they look more or less the same. So schedule, there's these slides that we're looking at. Our database for our live coding, so you'll need to have forked the repo and have some knowledge of where you've put it, because you're going to open the SQL database from DB Browser to SQLite. This is different for you guys have been working in VS Code, and you will continue to work with VS Code for all the rest of the things. But for SQL, we're going to use a different tool. This is normal for SQL setups. It's not something weird I've done. It's just sort of how it tends to be. So what you'll want to do is make sure you know where your GitHub repo, like mine's in my documents, where it's at, so that you can navigate to the database and open it up there. I'll show how to do that, but just make sure you've done a fork and you cloned it down and have it on your local computer. All the in-class code will be on GitHub. I'll post it after the class. Usually I'm pretty quick about it. All your assignment details and rubrics on how you'll be evaluated are there. And then just your typical policies, due dates, etc. Let me just show it just so that it's there. I'll say one thing about the slides. A while back, DSI wanted to do a big slide standardization process, but I felt that I did it, but I felt that I lost some of the pedagogy from my slides. So I have in my folder called 04 this cohort, you'll find that this custom slides folder, all the content is the same. I assure you that all the content is the same, but the visual presentation is a little bit different. The way images are rendered and things like that. So I will be teaching from the HTML versions of these slides. There's a PDF version of these slides. You'll also find all the same content here in the 01 materials slides folder. Apologies if that's ever confusing. It usually hasn't been. All the content is the same, though. That I want to just say that to you. In the O2 activities, you'll find your assignments here. There are 2 assignments for this class. I'll go into details of them. You can start on both of them now, technically. in the assignments, I'll say about when you can start working on sections. They're broken into 4 sections, and SQL is going to be pretty tight with the deadlines. I've talked with the admin about this, so do stay on top of it. It's easy to fall behind with DSI, and I know you all have other research too, but do take some time to kind of plan out how you think you'll go about doing the assignments here. Let's see, did we? Instructional team, you guys won't see that. In this cohort, we'll also have our live code. So we'll populate 2 through 5. I'll put some stuff in 6 too that we won't go in together, but in case you do find you really want to know about normal forms, they're in the 6th deck. And I'll put some code that's related with that. So each of that, you'll come in here, they're currently empty, but you'll find some .SQL files as we go along. And finally, the 05 SRC, you'll find our SQL database there. It's called the farmersmarket.db. I'll go over how to open it up together, but just now you have some familiarization with the GitHub repo. I always make changes to the repo. I find out I misspelled Kelly's name. I'm like mortified by that right now. So I will go and make changes. I recommend you go back to the repo and make sure that you have the most up-to-date things. I'll never push any major content though. It's already been pushed. This course is an introduction to SQL. At the end of the course, I hope that you'll feel comfortable writing SQL code, that you'll know how to search for the right things on Stack Overflow, that you know how to read some documentation, you know what questions to form. If you're familiar with SQL, we won't cover these more advanced topics, stored procedures, triggers, jobs. We won't do DBA work like monitoring or setting up a server. We won't really do much complex ETL or tooling or anything like that. Fortunately, I don't think from the pre-assessment survey that pre-survey that you guys had too much of that, but that's pretty typical for the adult upskilling that we do. And we'll use DB Browser for SQLite, as I mentioned. So there are 2 assignments released at the start of the course. They're broken into 4 sections, sorry. Section 1, which focuses on database design. Section 2 and 3, which are on SQL writing. And Section 4, which is an ethics-related prompt. Typically, the 6th class also has a 1-hour ethics conversation. Since I do ethics in day-to-day work, wanted to retain this despite losing some of the losing those hours. So I have pivoted those to a written response for you all. I think you guys will all have great perspectives, a great ability to do research. I don't want you to like dive into this so heavily that, you know, it consumes you. Like, I'm not asking you to write me like something amazing, but I would like to just have you read an article and respond to some of the ideas that I've prompted, or your own ideas from reading it. It doesn't have to be the same rigor that you might expect. Like, I don't need a super long bibliography. I just want to hear some kind of responses on what we've read. It's just kind of purely out of interest for me. Each section states when you can start working on the answers. As I said, if you have questions, come to the office hours with the course support. The database design sections are a little bit more time consuming, especially for assignment 2. I just put here in bold, do not put this off too much. It takes a little bit of time to think about and figure it out. The SQL sections themselves, where you write the code, are designed to be relatively easy. There are some hard questions, and really what we're doing is reaffirming what we wrote together. And when you do the work yourself, it really helps to reinforce that learning, right? And I always add that ChatGPT or other Gen AI probably doesn't help you too much. I don't know. Some people have tried, but SQL isn't the best GPT. It's not quite as good at things like that. How you'll be assessed: the pass-fail course, do the work, pass the course. Assignment 1 is worth 30% of the mark. Assignment 2 is worth 70% of the mark, because that section 1, the database design component, is a little bit heavier. You can review the rubrics for full details. And class attendance isn't assessed, but you should come anyways. And it's great if you let us know if you're unable to attend. Of course, you should code along. It's the best way to learn. As I mentioned, the rubrics here, they're found alongside the assignments. So you see in the assignments here, there's assignment 1 markdown, assignment 1 rubric markdown, and then assignment 1.sql. So the markdown will tell you what to do, and you'll actually write inside of it as well. The rubric will tell you how you're evaluated, right? And the .sql file, that's where you can do your .sql coding. So you'll submit those things. And there's instructions on what exactly to submit for those. Myself and the learning support, we like to be nice and flexible on stuff like that, but we also try to provide good framing for you all to kind of know what's expected of you. Okay, let's take a few minutes. Questions about the course layout, the assessments, anything I can answer? Yeah, Ethan, please go ahead.
Okay, this is just a minor one, but so this course will not be on U of T time, or will it be on U of T time?
What is U of T time? 10 minutes late?
Starts 10 past, yeah.
It's like going to be 5 past because thank you. Because the cohorts that are the upskilling professionals, they don't know about U of T time. So when so they always come 10 minutes early or on time, but 10 minutes early to U of T time. So I'll just meet you halfway in the middle here. 5 past, maybe 8 past. So yeah, thanks for asking. Anything else? No worries. As they come up, we'll address them. All right, let's talk about what SQL is. Oh, quick technical. Oh, Richard, please go ahead.
Yeah, this is just a quirky thing, but so I work with a lot of francophones, and there is no SQL en français, so nobody calls it SQL. They just call it SQL.
That works.
So
it's gonna be the first slide.
So if you're working with francophones and you say SQL, they may look at you funny and say, "What are you talking about?" So just a thought.
I love it. I will add that, Richard. I find that's going to be great. Thanks so much.
Yep.
Okay, just a note here on installation. If you don't need to do this right now, but SQLite browser here, DB browser for SQLite, here's the downloads. The typical issues with downloads are you picked 32-bit instead of 64-bit if you're on Windows. Sometimes, and I don't expect that with you all because you likely have your own laptops and not a work laptop, but sometimes if you do not have admin rights on Windows, you can use the portable app, which will allow you to not require you to use admin. If you're on Mac, you can either use Homebrew or you can download it. Nobody's ever had a problem on Mac. So if you have problems with this, reach out to course support, come for office hours. And yes, this is the same as what I put in the welcome email. I mentioned this, please download, clone your farmers markets. This is direct link to the database. Let's do this all together. Let me show everyone, and then it will also be on the recording. This is exactly what it will look like for a DB browser. If you're on a Windows machine, these sort of like tabs, they get like left shifted a little bit. You also likely are going to start in the bottom right on remote. Personally, like DB schema better. You'll come, it'll look kind of empty like this. Sometimes these sort of windows are all configured a little bit different. Your text size will look a little bit different. In the top left corner here is Open Database. When you open database, it will prompt you for a file window here. Navigate to where you have your GitHub repo clone to. So for me, it's in my documents. And you'll find here in the 05 SRC folder and the SQL folder, you'll find the farmersmarket.db. You can go ahead and hit open. You won't get these OKs that I will get. And so if you've done that successfully, you'll have 10 tables loaded, and you'll likely be at the database structure. We'll go up through all of this again, but I just want to show once what it looks like here to open up that database. So starting in that open database in your top left. Okay. Good stuff. We'll do it again. Okay, let's talk about what SQL is. And we won't need DB browser today, so just want to show you also that you know how to do it if you have some time between now and next class. Okay, SQL fundamentals here. So SQL, it stands for Structured Query Language. It's pronounced as either SQL or SQL. I like the addition of the francophone for SQL. That makes sense. I've heard it both ways throughout my career. Some people are really like have strong opinions on this. You'll hear I've said both. I tend to say SQL. SQL is a query language rather than a programming language. There's a little bit of nuance here. Querying is closer to telling a computer what you want rather than what it has to do. SQL code is often a little bit less reproducible than other programming languages because it becomes quite domain specific. Some SQL code, especially more advanced procedural code, does tend to be reproducible across the same flavor. I'll talk about flavors here in a bit. When we talk about SQL, its domain is databases, and it's based on set theory. I don't get into the set theory stuff. If you know it, it will help you. If you have never heard of it, don't worry. It's a way to think about it, and when it has sort of its mathematical basis on, it's not required. Tends in academic spaces to take up a lot of time in the academic space. And let's talk about exactly how this relates to the set theory or the algebra of things. I never found that very useful. It's a very practical language. Its purpose, its design is to manage data within relational database management systems, RDBMS for short. Some of them include MS SQL, so Microsoft SQL, Oracle DB, made by Oracle, MySQL, MariaDB, these are common open source ones, and also Postgres. SQL is also a common one, as well as SQLite, DB browser for SQLite, for example. Like your other programming or query languages, SQL has reserved keywords or commands to perform the instructional operations. Generally, we write these keywords in all caps. This just tends to be how people write it. Most modern interpreters don't require this, but it's just sort of the expected standard. I'd also say it can vary by organization. And organizations I've worked, everyone wrote lowercase SQL. Feels real controversial to say that. Statements, queries should end in a semicolon. Some SQL constructs, like common table expressions, and we'll get to those, will require them, but they do tend to be optional. I will likely kind of use them, forget to use them. And there's some debate on whether or not it's best practice if you really get into it. But so if you see that, just know that a semicolon is terminating the query that you have. In SQL, white space or line breaks don't matter. This is really different than Python. You guys haven't gotten to Python yet, where Python's very, very strict about where you can put white space and line breaks, and you have to like tell it that you're going to put line breaks into code. The emphasis for SQL is on readability. You want to keep SQL statements to a reasonable screen width. You want to include sensible line breaks, and you usually want to offset subqueries, for example, with indents. So you'll see a lot of different small changes that people make as they write this. It's because there's flexibility in exactly how it's presented from a formatting perspective. The syntax is the same. It's just whether or not you include a line break or where you put this comma, in relation to that line break, for example. Code is commented in and out with 2 hyphens, 2 dashes, rather than the more common pound sign. And you can take full code blocks out with the /*//. Looks a little bit like this here, where you have your code that spans multiple lines. You can pop it on either side of it, and that will comment it out. If you're not familiar with the term comment in and out, that means whether or not it will run or not run. If it's commented out, it will not run. If it's commented in, it will run. Let's talk about the flavors here. So RDBMSs, they differ from one another. SQL has a long history. It's not a young programming or querying language. So there is a lot of diversity that exists out there. So you have different keywords, for example. So if we wanted to return the top, only 10 rows, we could use select top 10 versus, and then the rest of the query, versus select, and then the query, and then limit 10. So the difference here is where we put limit and the word limit or top. So you won't have a mix of this. You won't have select and then the query and then top 10. You'll either have top at the front or limit at the end. You can see how this can be a minor difference here. It will mean that the RDBMS doesn't return the results. It will err on you if you're programming in the wrong flavor. But the good news is especially with the internet now, right? You can easily search like, I want the top 10 queries and I'm in SQL, top 10 rows and I'm in SQLite, and it will point you to limit. So you'll be okay. There's different syntax for other things like not equals, for example, exclamation equal versus less than greater sign. Sometimes they support both. There's also more nuanced and complex differences like architecture, data types, and things like that, which we will touch on a little bit more. So some things seem very superficial, but there are also some that are significantly different. We're using SQLite. It's easy to get set up. It requires almost no overhead. It's open source, it's free. It has really similar syntax to other ones, so it's great to learn on. And it's used all over the world in loads of applications. For example, Firefox, and I learned last cohort that Google Chrome also does this. Your history is being written to a SQLite backend locally on your machine. It's called SQLite because it's lightweight. It is so easy to just embed SQLite into web apps, for example, that it's all over the place. People almost kind of never think about it because it's such a small, kind of perfectly contained little thing. But web developers love it. It doesn't tend to be what you see in big enterprises for their SQL databases. They tend to use Oracle or Microsoft, for example. Or cloud things, now that we're in the cloud world. Some broad observations of the open source systems, just generally here. They're excellent at what they're designed for. So SQLite being really small, that's what it's good at. Having low overhead, that's what it's good at. You have some variance in your data types. SQLite has some unique ones. But they do also tend to be other data types that exist in other programming languages. They're not just making things out of nothing. You'll find that in the open source systems, not every command exists. It doesn't have all the bells and whistles, right? But workarounds for those commands are almost always possible. Sometimes it just takes a little bit longer, a little bit more complex syntax instead of just using a single keyword that maybe exists in the RDBMS commercial ones. And sometimes they feel or they look a little bit outdated. On the other side, we have our enterprise systems. They're really powerful. They're designed for the edge cases. They feel like quite refined, but I can say this is also version dependent. In my first role out of undergrad, I was working on a 2005 SQL box, and it was kind of a horrible experience. Even though it was Microsoft, 2005 SQL and 2012 SQL were like massively different. So that version really matters. Same thing in Oracle land. Alex, we'll get to your question. They tend to lock in businesses and organizations. Sometimes migrations are so costly that organizations just stick with their choice that they made in the early 2000s, and they're still with their choice. There are newer players. I'm sure you guys have heard of Snowflake, Databricks, et cetera, and all the cloud providers also, Azure, AWS, GCP. They offer more functionality than just database querying. And sometimes when you have database querying tools in those cloud or those new players, they sometimes will use different terminology to describe those SQL tasks. So that can mean if you're working in a Snowflake environment, you just have to kind of like tack on to your web searches, like what you're trying to do, and then add Snowflake to the end of it. And then you'll get to the Snowflake docs and you'll know exactly what you have to do that's slightly different. Let's talk about the different environments here. Databases are sort of our fundamental thing here, right? So relational databases are a collection of tables, views, procedural code, and other SQL assisting artifacts. Generally, the data stored in a database is going to be related to a real-world concept. So you can think of the backends to data collecting systems. So CRMs, for example, EMR software, ERPs, web-based applications. If it collects data, it's likely writing down to a SQL database. They're not always connected to one another, even if they're like they can be on multiple servers, for example. It's usually determined by the business if it's necessary for that. They're often transactional, which means data is actively being written to the database by the front-end system. And tables for databases tend to be normalized. We're not going to get into normalization, but there's going to be a few. Describes exactly how the data is kept and relationships between the data. It's a big topic. There are also non-relational databases, like those that are often referred to as no SQL. We're not going to cover those, but some common ones are tools for these are Amazon Dynamo, Azure Cosmos, MongoDB, and Google Cloud Data Store. So if you're familiar with any of those are no SQL, and they use different things, key pair relationships instead of to define instead of having key relationships. Data warehouses and data marts. Data warehouses are highly structured collections of usually tabular data. The data, in the case of a data warehouse, has been processed for a specific purpose. Usually that purpose is analytics. So you can remember the database has that kind of transactional feel to it. A data warehouse will take those transactions and make it so that it can be centralized. You'll do that centralization with the assistance of like an ETL, that's extract, transform, load, or ELT, which is changing the order of things. The tools that exist to help you move the data around. Data warehouses have a lot of overhead. They require governance, and they need strict rigidity to work. Your tables become denormalized. That means you're taking apart the table and making relationships instead. It's common in enterprises, but I'd say it's also losing traction. A lot of big organizations have data warehouses that they built, a couple of decades ago, and they're sort of slowly moving away from them. But it took them, 10 years to build it, so they feel some attachment to it. They're super useful when they're built well. When you have data warehouses, you tend to also have data marts. A data mart will be created from the data warehouse to focus on like a single subject. So you could think like sales, for example. It's designed to make the data warehouse a lot easier to use because data warehouses are really hard to query from. The data tends to be structured but flexible. It's driven by the purpose of the data mart. So you'll see a mix of denormalization and some normalization. And you can even go further down the normalization path. And this is really subject by the purpose of the data mart. And so when you get into like intense database design, these are the types of topics that kind of come up, and to determine exactly how you're storing data and how easy it is to query that data. Newer, now we have data lakes. Data lakes, think of them, they're like big storage pools. They allow an on-demand access to raw, semi-structured, structured, and unstructured data. A big difference here between like databases and data lakes tends to be databases are really good at structured data, so tables. But what are you going to do with all the unstructured data of the world? That's text data that's coming in, the pictures, etc. Those tend to be more like unstructured data. Semi-structured, it's like your XML things, JSON file formats. So where there's some structure, but it's not defined as tightly as a table is. Data lakes aren't usually defined by a specific purpose. Usually they're just a space to store things. So they're super scalable. Sometimes they're transactional. It depends on the systems that are interacting with it. So if there are systems that sit on top of the data lake, if they're producing directly onto the data lake, they can be producing those transactions. Transaction, if you're unfamiliar with sort of what I mean by this term, it's like an instance of data being created, right? So you're interacting, you're signing up for something online. That's a transaction, right? You're making a purchase on Amazon. You click buy. That's a transaction, right? So each time that these rows are created. Data sources for machine learning pipelines a lot of times tend to live in data lakes, especially the more unstructured one. If you're going to do a bunch of image recognition stuff, you're probably going to point to a data lake. It will make a lot of sense. They're a lot cheaper, inexpensive compared to data warehouses, though I'll just add as a caveat, like when I made this slide in 2022, the cost for cloud computing was much different than it is in 2025. No shock there. The price of cloud computing has gone up substantially. I'd say it's common for enterprises to shift towards data lakes, especially with support for newer tools like Snowflake or Databricks, which really maximize the analytic value of data lakes. Data lakes don't themselves imbue analytic value because they can just become storage pools, but you can put these tools on top that start to allow you to sort of derive out from it. They can also become data swamps, which are just your poorly governed data lakes. So it's easy for a data lake to have a lack of documentation, a lack of governance, be poorly designed, and they become swamps for that. It means that there's no discernible source of truth for the data that you're finding in there. You might have repetition, but somehow it's slightly different. That's sort of the downside to an ungoverned data lake. If you're building them, you should avoid building them. What questions do we have? We have a couple here in chat here. There was a question on what RDBMSs were. I'll get to that still. But you should think of RDBMSs as sort of literal software that was built to help manage the way databases interact with one another. But we'll get to the details. Alec asks, when we talk about Facebook storing and selling user data, are these data extracted from data lakes? I don't know for the case of Facebook and Meta. These are... I think it would, you have to remember for an organization like Meta, we're talking scale that is unprecedented, right? Some of the biggest in the world. So they're going to use different structures to help. They're going to use different structures than perhaps what you'd encounter at other organizations. But I can imagine that for analytics and things like that, they're absolutely going to use data lakes. They're absolutely going to have databases. It's just going to really depend on exactly for a data organization like Meta, which is predominantly what they are. They're going to have a huge array of technology. And same would go for Alphabet, for Google. Good question, though. You have to really think about it a little bit. Can we give a general definition of a database? I'll get to it, but I think when we're talking about a database in this context, really we're talking about this collection of tables, and these tables are correlated to all the next section. So we're definitely getting there. Normalized and denormalizations, let's not worry too much about it, but I like to kind of put the little tickler. It's worth looking into if you become interested in database design. It describes how you all, I'm sure, as researchers are used to populating tables here that have, a response and then some value associated with these different observations, right, and attributes for those observations. When you do database design, you can split those things apart so that you can reference different attributes differently. You can have a table that is just associated with the colors, for example, of your, if you have an attribute colors, what color is this plant? You might have a table just for colors. You might have a table just for size. That's what denormalization starts to look like, where you're taking apart a row of data and splitting it out. I'm confused on the flavor. The flavor, so some of the flavors, T-SQL, that's Microsoft SQL. PL SQL, that's Oracle SQL. SQLite, that's what we're using. MySQL, that's another. Flavors are like you're still eating the same food, but it tastes a little bit different, right? So just this, that's why they call them flavors here. It's like your keywords are going to be just a little bit different. And it's the way that the development, the history of it kind of came and changed and led to people solving the same problem, but ending up with slightly different results. So you have different data types, for example. We'll get into data types next. But you might also just have different syntax, different words. You want to do the difference between two dates. You can use some flavors might have date diff. That's the command, and others won't have date diff. So it's like a different version. Well, so SQL then also kind of has its own versions too. So Microsoft has SQL Server 2005, 2008, 2012, 2014, etc. Those are versions for SQL, but T-SQL is its flavor. So it's kind of like this the type, the syntax, the type name of the syntax that's related to it. Crystal asks, can we summarize the discussion about databases, data warehouses, lakes, etc., as different ways in which data is stored? Yeah, absolutely. That's a great way to summarize it. Yeah, the way you store data, the bigger it gets, right? The more you have to think about these things. When you're working really small, just a few, maybe a few thousand records, you don't have a ton to deal with this. But yeah, there's a huge amount of variety out there. When I worked at Thomson Reuters, obviously what Reuters has related to news things is way different than what the accounting team at Thomson Reuters might have, right? Great questions. It's weird to think MATLAB and Python don't have dialects, that their dialects vary within their versions. Yeah, that's true, right? Python 2.7 and Python 3, massively different things, right? Some of you also, I love, Alec, you brought up Microsoft Access. Access is a SQL database. It was a tool that used SQL databases offline before there were servers. So if you're familiar with Access, you know some SQL, whether you know it or not. Great questions. How are we doing on time here? Oh, we're smidge early. Let's take a break here. Take 10 minutes. Come back at 4:03. I'll go off camera. See you all in a bit. Ethan had a question I missed in chat, and the hand went up right as we said we were doing break. So coming back to that. The question was, is Excel a database? It's a more complex question. Excel is a good place to store some data sometimes. If you have a small project, it can be super useful. If you are an organization, Excel can be very much a kind of a double-edged sword. It allows for data collection, changing, manipulation. But because of that, it also means that you have sort of this ability for anyone to come in and make changes to data, and not even very traceably. You can make a mistake in an accounting thing. Oh God, it's so common for them to just go Excel crazy, really complex formulas and things like that. And they're really hard to discover because all that code is sort of buried in your formula bar or something like that, versus like writing a Python script where someone can like read the Python, it's all right there. Programmers generally not a big fan of Excel, but we all know it's a super useful tool. So it's sort of just like is the database? Maybe. In the context of SQL, probably not. And I would say a lot of SQL practitioners frequently deal with the sort of question from the business saying, at enterprises, for example, saying, well, it's in our database. And then we say, what database? And they say, well, my Excel workbook. That's not a database. That's your Excel workbook. And it's not controllable. It's not production. So it's a great question. I really appreciate it. It can really depend. And when we talk about importing and exporting data, we'll talk about CSVs, comma delimited sheets. A lot of people use Excel to open. Excel just it sort of serves a purpose, but it also is a tool that really overreaches as well. There's also a question here about confusion around data lakes. So I'll just go back to it, what I've written here. When we think about data lakes, think about a data lake as a space you could save anything. So if you have live traffic data streaming in from 5 million sensors, right? So cars going by. You're writing a single line to likely a JSON format to say new entry, new entry, new entry, car went by, car went by, car went by. Because you're having such a volume of data, you probably want to store that in a different way, likely not a SQL database, actually, likely something like a flat file, like a JSON file instead. It's more portable, it's more storage friendly. A data lake is a great space to store something like that because you have access to it as an analyst, as a data scientist, engineer, etc. Because it's directly where that sensor is creating. Maybe you have a process that moves it to a production. There's some tools that go from development to testing to production, make sure that data flows. A data lake's a great space for something like that, where you're just creating an immense amount of like what we used to call big data, like in 2010s, people talked about big data endlessly, or we had LLMs, and that's now all we talk about. So a data lake really can be just any of these things. When we talk about LLMs, large language models, GPT for being an example of that, right? It's trained on this great big corpus of text data, right? That text data, not going to be good for a SQL database. Text doesn't go well like in huge long streams. So if you're familiar with how GPT was generally trained, it was used the common crawl, right? Which went and extracted a whole bunch of data, a lot from Reddit, not a great place to train your tool, if I'm honest. And it said, all right, let's do some complex math, build our transformers out. Doing that, you're probably going to use something like a data lake to store all of that unstructured, just textual data, everything that Thomas ever wrote on Reddit, right? That's all just kind of like junk data, right? Really good, unorganized, but it can be tagged with, this is where it came from, this is who the user was, and you can also add more details to it with your Python code, for example. You can say, okay, the content is this, the toxicity score is this, the theme is this, right? So that's a space where a data lake would be much better than something like a database instead. When we talk about tables, and we'll get into this here, the big thing that databases help with tables is about establishing relationships between the tables. That's what we'll go to next. And that's why we mostly talk about databases in the SQL context and less about data lakes. But I want you kind of to know the landscape of these things. It's useful. Good questions there. All right, we did 358. 407, coming into our data modeling here. You guys are already kind of predicting, your questions are very much on like exactly as we're going along. You're saying, wait, what's an RDBMS? Or tell me more about what relationships. So that's what we're getting to. How is SQL different from something like Pandas? Yeah. SQL's bigger than Pandas or data frames or dplyr and R. But it's really similar. It feels really similar. So if you know Pandas, SQL querying's gonna feel really similar to Pandas or dplyr, or these things are all really do tend to start to look the same. Back up to the 80s, they look different. So that's sometimes the age of SQL showing itself. Now things seem like synonymous with one another, but it wasn't always like that kind of thing. All right, let's talk about RDBMSs more. Lots of topics. Okay, so it's been asked, so what's an RDBMS? So a relational database management system, it's software. It's designed to store large amounts of information, utilize a query language to allow for the easy retrieval of the data. That query language is SQL. Allow multiple users to access the data simultaneously. This used to be big. I know, like nowadays we're all in the Etherpad together. You guys, right? Your Google Docs, everybody interacts with one another, right? But that wasn't the case. Like things used to not be so interconnected, right? They were really like you worked on your machine. Well, SQL servers allowed for analysts to access the data simultaneously as a system was writing to it. This was a big leap forward, right? So that's why RDBMSs are a thing, right? It also manages permission for data access. So that's a big thing too. Who is allowed to see this data, right? That's very different than, say, an Excel document. And also do some more specialized tooling around like data corruption mitigation, preventing unauthorized access, for example. So the software is more than just storing the data. It's more than just the query language. It's the combination of all sorts of these little tools. There's procedural engines that run, if you're familiar with like a cron job or something like that, SQL has like the RDBMSs have an equivalent to that. Jobs that can be scheduled and told to run every day, run this. Right, so that's where RDBMSs are more robust than just the data within them. Generally, we store data in the SQL context in a database. And you can think of a database as a collection of information, right? Within a database, we'll have a collection of objects. Those objects, likely tables, we're storing them. RDBMSs do one more thing here, which is they allow users to define the relationships between objects. And that's the interaction between these objects. I've kind of hit these ones already. Procedural scripts to query specific data or trigger an action. Those are super useful. Scheduling those routine works, procedures to run, maintenance, etc. So lots of different ways that those object interactions exist. Let's talk here about our data models here. A data model you can think of as a notation for describing data or information as it's being stored. So a data model consists of the structure of the data, the operations in which you can perform on the data, constraints that exist on that data, and then the relationships between the different types of data, or the different objects of data. You should say objects rather than types. We'll get into each one of those. We'll talk now structure, operations, constraints, and relationships. So the structure. I've said SQL is comprised of tables. Here's a table, dog breeds. Tables have attributes and observations. And in SQL, we call the attributes columns. So breed, coat type, coat length, and observation. So these are your rows. So Samoyed, they have double coat and it's long hair, right? And our databases require these tables to be named. So we could call this breed underscore traits or breed traits, whatever you want, breeds. Columns are defined and therefore restricted or constrained by their data types. I've talked about data types a bit already. Some common ones include int, so integers. These are your whole numbers, 1, 2, 3, minus 1, 2, 3, 1 million, whatever. Most systems conserve space by specifying the range of the integers, so the size that the integers are allowed to be. Remember, the context of SQL still useful in 2025, but go back to the 80s, space was a luxury, not something you have 14 terabytes sitting right next to you, right? So the constraining of size of an integer actually would make a difference. We have float, decimal, real. These are ways to articulate decimal values, 5.5, 3.333, 3.14, whatever. We have varchar, nvarchar, text. These are your text strings. So usually you also specify a maximum length. They're going to be in single quotes, A, B, C in single quotes. Date, time, time. These are your dates and your times, right? And dates and times we'll get to, but let me just say that dates and times in every programming languages are a headache, and SQL is no different. The way you store dates, is it year, month, day? Is it day, dash, month, dash, year? Those are all valid questions that SQL also struggles with. SQLite likes to be really restrictive on dates. It's one of the places it's more restricted. The rest of the time, SQLite tends to be a little bit more generous on its typing. And you'll see typing varies by flavors. Some are simple, some are complex. It just depends. Ellen, to your question here, I don't know how many discrete data types there are. I think it really just, I mean, these are the common ones. And sometimes you have the same thing just like renamed. So instead of nvarchar, you'll have text. And they're the same thing, more or less. Data types are important here. They affect the operation speed, the storage size, and the validity of data. So speed, it's computationally less expensive to compute smaller values. It means it's faster too. For storage, small is usually better, but the wrong size can actually have effects on systems. So real world example where this kind of fascinatingly reared its head. You all remember back to the popularity of size Gangnam Style. When it exceeded 2,147,000,000 and change views on YouTube, the view counter stopped going up. That's because they stored this as a 32-bit signed integer. Now they've expanded it to be a 64-bit. This is specifying how big it's allowed to get, and it's allowed to get significantly bigger. I think this is always supposed to be trillion. I think it's 9.2 trillion. So a lot bigger. Should check that one. Validity, ensuring that the columns contain the right type of data for the operations. So if you ask it SQL to do 5 plus TEN, well, humans, we know TEN, that's 10, that's 15, but SQL doesn't interpret 5 plus TEN as 15. It says that's an error, that's invalid, right? Going back to that Excel question, this is again where you can have those kind of minor mistakes where someone stores something slightly wrong and all of a sudden your computations aren't coming out correctly. SQL actually puts a lot of, the RDBMS has put a lot of structure around this, to prevent you from loading in data that's not valid or not allowed. And a data model is what determines whether or not it is or is not allowed. So it's our structure. Let's have a quick Mentimeter here. The way these works, I'm just going to show a question. Here's a link. You can go on your phone, you can go on this. Live. What data type is the column breed most likely to be? Don't write it in chat, write it in the Mentimeter. So select the right answer. Wait for a few more people here. Do like 2 of these per class, so just take like a minute. Okay, overwhelmingly, everyone has said varchar, right? So it's likely to be varchar because it's text data. Great job. Super easy one. Get us started. Oh, I lost my chat with that. It's very strange. There it is. All right. Let's talk about constraints here. So data models, they also specify our constraints. Constraints are rules that must be followed. So here are some of them. The referential integrity constraint. This ensures that values in one table has a or a set of corresponding values in another table. We have attribute constraints, so ensuring that certain types of values are always consistent within the column. This can be, for example, ensuring that values in a column are unique or that they're not missing, things of that nature. Here are some examples of constraints. Null and not null. This specifies whether or not a value in a column can be missing or not. So in SQL, we use null, if you're familiar with Python, R and A instead, right? But so it's null and not null. Unique as it sounds. So this means in a column, whether or not you can have any duplication or not. So if all the values are different. Primary key and foreign key, and we'll get to these, but I'll talk about them here now. What they're doing here is they're ensuring that each column in a for primary key, each column value in a column is unique within the table. So you could think of it, for example, an ID field where each row has its own ID. We specify one primary key per table. It can't be null. And what it's doing, if we go back to our referential integrity constraint, is it's ensuring that record deletion cannot occur, therefore ensuring database integrity. So where's my little pen here? So if we have, for example, we're going to have our products table. So our products table, I don't know, corn, lettuce, etc. We're going to have our customer purchases. That's P. The key here is going to say that if we have a record here, we can't delete the corn value in our product table if a customer has purchased corn, because it would make it so that that corn value was all of a sudden kind of a big question mark, right? So that's what this primary key and foreign key are going to be doing. We'll keep going on them, but I want to just kind of demonstrate a little bit what that looks like. The foreign key is the opposite side of the primary key. So creating the linkage between a column in one table and a column in another. So usually you're going to link foreign keys to your primary keys. Sometimes they share the same name as the linked column, but it's not required. So product ID and product ID. The linkage does require that the data types are the same. So say product ID for corn is 7, 2, or 1, it's an integer. So it's expected in the customer purchases table that the product ID also is an integer, 1 or 7. So it's always going to be, and they're going to be the same, right? You can have as many foreign keys as you need per table. Foreign keys can also be null, and the records can be deleted. So go back to my little diagram, which I've deleted, unfortunately. But if this was our customer purchases and this was our products, we can delete this record that said Thomas purchased corn, because that doesn't have any downstream effects on the product table. Corn still exists as a product. We can't go the other way. We can't say, let's delete the corn because the purchase still exists, right? We'll get into all of it a little bit more, but just it's really good to start touching on what primary and foreign keys are. Jershan asks, does the primary key also require values to be sequential, or is that something you specify? Yeah, it's a good question. When you have an ID field, you tend to use like auto increment, for example, which would be ensuring that sequential. But you don't have to have an ID field be something sequential. It just tends to be. Like it'd be a little odd to call your IDs something different than 1, 2, or A, B, C, or something like that. But I mean, sky's the limit. You can make your IDs an ID. And so keys tend to be like IDs, but they don't necessarily have to. It's just going to be the best practice. So essentially, SQL is a way of navigating and collecting data on a large scale. Yeah, it's a great way to put it. Are the rules governing how the data is arranged and collected? Yeah, the data model is the set of rules. So the data model isn't predetermined by the data. It is to an extent, like philosophically, but it's the humans that look at the data and they say, this is how we want to organize it. This is how we want to optimize it. So it's more of a way of thinking about it. Let's talk about some diagrams here. Will help. So ERDs, entity relationship diagrams, are diagrams depicting the structure of tables within a database. So what I literally just drew, that was like a microscopic ERD, right? So it's identifying the table and it's describing their relationships. They're useful for designing the database. They're very useful for debugging a query, and they're really useful for writing logical, consistent, and efficient queries, which is important in SQL. Efficiency, when you start to have bigger and bigger data, actually can determine how long you have to wait for data to come back. I'm sure if you are writing stuff in R, you know this. Sometimes you just wait and wait and wait for that result to come. Well, that's driven by your efficiency. SQL has engine optimization through keys, through indexing, that helps this go faster. We have 3 levels, and the levels are depicting the detail of ERDs here. So conceptual model at the top, logical model in the middle, and then physical model at the bottom, the most detailed. Let's talk about the attributes of an ERD, our entities and our relationships. So for a given ERD entity, so an entity, an object, like a table. There are other objects aside from tables, but in the beginning, just think about tables. So for a given table, think of the name of the table. So our breed traits for our dogs, the relationships to another table, if they exist, the column names, the column types, and then whether or not there are primary keys and foreign keys present. Those are the attributes that we have of an ERD entity. So each entity has its own set of attributes. For the relationship, we define which columns are going to be related, and then we define what type of relationship exists. So a one-to-one relationship, a one-to-many relationship, a many-to-many relationship. Those are the 3 types of relationships. Some people ask, are many-to-one relationships? Yeah, it's the same thing. It's just directional, right? Let's talk about each of those type relationships. Okay, so a one-to-one relationship where a given row within a table is associated with only a single row in another table, right? So Canada has the capital city of Ottawa. There's only one capital city for a country, Canada to Ottawa. USA to Washington, D.C., Mexico to Mexico City. So a one-to-one. If we have 2 tables, the first table is country and the second table is capital. We have 1 record Canada and 1 record Ottawa, hence the name one-to-one. You can visually describe this here. Just have 1-to-1 here. You're drawing a linkage between those 2, and there's only a single line of linkage. One-to-many, where a given row within a table can be referenced by multiple rows in another table. So Canada, so it's country to states. So Table 1 is country, Table 2 is states. So Canada has 13 provinces and territories, right? Alberta, British Columbia, et cetera, right? So in the province or states table, we're going to have 13 rows associated to the one row in the country. Same thing for the US, right? 50 states. Same thing for Mexico, 32 states. Sorry, seems my last column got cut off there, last row. So you can see how when we're drawing this out, we sort of have our table 1 is Canada, right? And that 1 is going to our mini. So British Columbia, Alberta, Ontario, et cetera, right? Our USA, same thing, Alabama, Alaska, New York, right? Mexico, go to Baja, Mexico City, et cetera. So we can see how each of these has many relationships, that the relationship is 1 on one side and many on the other side. There's a number of rows, the association. We're describing that kind of real world relationship, saying we're describing that hierarchy, right? There are more than one set, like states, provinces, et cetera, within that country. About many to many here. So where multiple rows within a table can be referenced by multiple rows in another table. So let's take, for example, country and membership, and let's define what European membership means for countries. So consider different ways here. So we can say whether or not a country is a member of the EU, part of the Eurozone, so uses the euro, or has abolished border controls, the Schengen Agreement, right? So let's take 3 examples here, 3 countries, Slovenia, Sweden, and Switzerland. Are they in Europe? All right, from the 3 different ways here, we can say one way to describe membership is the EU, another way is the Eurozone, and another way is Schengen. Okay, so for Slovenia, which I'm saying country ID number 1, we can ascribe a many-to-many relationship here where we're going to all of these different spots where they are part of the EU, where they are part of the Eurozone, and they are part of the Schengen. So if we ask the question the opposite direction, who is part of the Schengen Agreement, we're going to also draw to different countries, right? To Slovenia, to Sweden, and to Switzerland, right? So that's where the many-to-many is happening. We go through for the rest of the other 2, right? Sweden is in the EU, but it doesn't use the euro. So we do not have a record for 02 to 11, right? That's where that Eurozone relationship would exist. And for Switzerland, neither in the EU nor using the Eurozone, but has abolished border control, would exist here just in that direction. So for each of these, we're establishing a many-to-many relationship. You don't see a lot of many-to-many relationships because they kind of make your head hurt. But you can think about it as when we're talking about what membership does country X have, but also the reverse of that question, what countries are in what membership, you will end up with different subsets of rows. That's a many-to-many relationship. You can see it here. I have to have 3 different maps to express the European Union, the Eurozone, the Schengen, to express the countries. So this is our many-to-many here where we have our EU examples, we have our Eurozone examples, and we have our Schengen examples, right? We can make it even worse, more complex, if we add the table for NATO, UN membership or something like that, because now we have non-European countries as part of the NATO and UN membership, right? So greater complexity there. And Darshan, you asked this great question here, would it be better or worse to do different binaries for the countries? This is just a mechanism to describe many-to-many relationships. I'm not necessarily saying this is how you should describe your European membership relationships, but this is a good example of that. And it's just primarily the question for data modeling is exactly how should we define this data? How should we build these relationships? And different choices you make have different caveats. We could totally redesign how this is done, never make a table like this with the country ID and the membership ID, and we wouldn't have those many-to-many relationships. So depending on how you go about how you think about this is going to result in a different configuration of a data model, right? So that's really the exercise of data modeling, is going through and thinking, how does this data come to be? How does this data come into the database? How will it be queried? These are the questions you sort of think about. And these are the concepts that are associated with this to help you think through it. Let's do another Mentimeter here real quick. Same link here. Don't write in chat, write in the Menti. You work for a retail store. The SQL database has two tables, customers and purchases. What's the most likely relationship between the tables, one-to-one or one-to-many? All right, great job. 40 people in. So one-to-many overwhelmingly. Good. So it's a one-to-many relationship, right? Because you can as a customer, you can purchase multiple things, right? So each customer is going to have its own ID. Thomas's ID number one, and Thomas buys, item number one, number two, number three, right? So we can have multiple purchases. We can have multiple items per purchase, right? So we can have a hierarchy that's established. There could be different ways to establish this relationship, but the most likely, the most common here is going to be a one-to-many relationship. Great job, everybody. Ethan, look at your phone and it shouldn't show you the answers yet. Like if you do it on yours.
I was able to see, oh, you have to do it on the phone.
Do it or on yours, like when you click the link, it
shows me everything.
All right, good to know. Maybe I'll see if I can tweak the type.
Thanks.
Menti changed all the types on me last cohort, so there may be some. It's good to have that feedback. I appreciate that. Let me make sure I saw a couple questions here in chat here. Can one say SQL is useful for ensuring the data is retrieved with ease? Yeah, 100%. That's really the goal of good database design, data modeling, right? Alec, I come back to your question and the pad. Kelly also knows a ton about NLP. Let's talk about the three different types of models here: conceptual, logical, and physical models. Okay, so conceptual models, what do? They define the tables, the objects, the entities, and their relationships. When we talk about our farmers market, so I'm just going to start to familiarize you with our farmers market. We have 10 tables, and we have relationships between these tables. So if we have product, if I'm a pen, product and product category, we're asking the question, what type of things a product is, right? So we have in the product table and the product category table, we have sort of like a hierarchy established, right? So our product categories are like fresh fruit, fresh veggies, whatever, right? And prepared goods, baked goods, right? Those are categories that then apples, apple pie, bread, lettuce are all going to fall into these various categories, right? We have our product and customer purchases. Product and customer purchases. Yellow's kind of hard to see, sorry. That's what products a customer has bought. So these relationships, they represent like a real question. Like we can articulate the question that these relationships have, right? What products a customer has bought. That's our relationship between the product and the customer purchases. Product and vendor inventory, do that in green. What products each vendor has available, right? Take a look here and just note that not all tables share a relationship to one another, but all tables have at least one relationship. So postal data here for example, has only a relationship here to customer, right? It's because it's related to the customer, but it's not related to the product. What's the postal data of a product? That question doesn't mean anything, right? What's the postal data of the product category? That definitely doesn't mean anything, right? Something like, vendor booth assignments at booth. Okay, it makes sense. Here's our booths. Here's all the booths that exist at the farmer's market, the stalls, right? And this is who got assigned to what on which date, right? And we can actually see on which date just by the nature of the connection to market data info through vendor booth assignments. I know, even without looking at the data, that vendor booth assignments and market data info, that means that, okay, clearly there's a connection to dates, and assignments make sense on a date. So I come in on day 1 and I'm assigned at booth A. I come in on day 2 and I'm assigned to booth B, right? Kelly comes in on day 1 and is assigned to booth C. Niaz comes in on day 1 is assigned to booth B, whatever it may be, right? We're going to have kind of like a temporal aspect to it. Logical models here. They add additional details to the conceptual model by adding column names for each table. So we're going to have our column names, and then they also indicate the type of relationship. So 1-to-1, 1-to-many, many-to-many, right? So let's look at a couple. This is just a partial. We went from 10 tables down to 4. It's just so I didn't have to build the whole thing out. Our partial farmers market database, so product. Grab my color again. Shares a 1-to-many relationship with vendor inventory. So we have the 1 up there and the infinity here, right? A 1-to-many relationship. And we say what on, so product ID. And we place that to product ID. There's lots of different notation ways to do this. If you've done this in the past, and you're like, I like crow's feet or whatever, Thomas, do it. I don't care. It's all good to me. These are just different ways of describing. I like the 1 in infinity marks. It's just me personally. If you're not familiar with the words I'm saying, crow's feet, you're like, that sounds something really different. Don't worry at all. It just means that there's different ways people have agreed that it should be written on these diagrams. I don't have strong preferences on it. Our second one here, product category. So 2 columns. Oh, I picked yellow again, sorry. All right. Our 2 columns, product ID, category ID, and product category name shares a 1-to-many relationship with product 5 columns, 1, 2, 3, 4, 5 on the product category ID. All right, here I've left the last one blank. Somebody type in chat here. Blank shares a blank relationship with blank on vendor inventory. So write out the 3 blanks. It's not product. I misspoke there. So blank shares a blank relationship with blank on vendor inventory. So table 1 shares a type of relationship with table 2. What are the 3 blanks there? Vendor inventory shares a many-to-one relationship with vendor ID on vendor ID. Yeah, we could go the other way with that too, right? Of the vendor ID many-to-one, 1-to-many relationship, right? So exactly right. Right, so vendor shares a 1-to-many relationship with vendor inventory on vendor ID. Good job. Right, so this logical model tells us a degree more what columns are there, what the relationships are, and on what columns those relationships exist on. Going deeper, one more into our physical models. We add the detail to the logic model, adding the key type and the column data type. I've gone even narrower here, just 2 tables here. So our physical model for our partial farmers market. So vendor ID, which is an integer, is the primary key for vendor, which shares a one-to-many relationship with vendor inventory on the foreign key vendor ID. And remember your your relationship here, they need to share the same data type, right? So integer and integer, they do. Product ID is a foreign key for vendor inventory. So elsewhere on the diagram, we connect this to a primary key of another table. Remember, I'm just zooming in narrower and narrower. There are still 10 tables. I just didn't draw them all out, right? It means that somewhere down here, there's a table that has a primary key on the product. It's probably the product table. And we have our PK, and it's going to be product ID, right? And it's probably a one-to-many, right? Okay, let's have a question here. What we're going to do here, Niaz is going to throw you all into breakout rooms. They're short. The breakout rooms, they're like going to be 1 minute. So I'm going to prompt you with a question here. They're going to be 1 minute, and talk amongst yourself for the answer to the question. I'm going to close the breakout room. The breakout room will have 60 seconds. Continue to talk for those 60 seconds, and then come into the Etherpad, like line 185 here, and write your group's answer. You don't need to say what group you are or who you are or anything like that, but that's how we're going to do these think pair shares. So you're going to group 3 or 4 of you to talk the question here. So prepping you for the first one on that. If you don't have an Etherpad link, here's an Etherpad link. I haven't said the question yet, don't worry. Okay, the question. Okay, so market date, which is a date, is the primary key for vendor inventory. Why do we think that is? So, Niaz, I hope you're ready here. Talk it over amongst yourself. Come back in just a couple of minutes. It goes by really fast. All right, Niaz, you want to close them if they're not already? Welcome, welcome. Take a second here, write in the Etherpad your response. Okay, let's see what people are writing here. Oh yeah, I like this one a lot. The date uniquely determines the inventory for the day. That's a great way to put it. As you guys are capturing some key things, right? Market date will be unique, right? Absolutely, right? But conceptually, the big thing is that you're determining exactly what a vendor is bringing to the farmer's market on that day, on that given day. All right. Was there a question? No, I don't think so. Okay. All right. What questions do people have about data modeling? Let's see what have I missed in chat. Question was, is the primary key always on a table that's a one-to-many relationship, similarly as a foreign key on a table that's a many? So the countries, so let's go back to the countries and capitals. So if we have our country table, 1, 2, 3, and Canada, USA, and Mexico, that's our countries table. When we have our capitals table, we have to have something that will linkage, right? So we have to have like a country ID, right? So CO ID. We also need a capital ID, right? So CA ID. And then the capital, right? So the country ID for Canada be 1, the capital ID, sure, let's change the notation to like 10 or something like that. And this is Ottawa, right? So the linkage here, and we have 2 and 20 for DC and Mexico City, and 3. These are all made up numbers, it doesn't really matter. But what does matter here is that the 1 for country ID is present here, right? And we have a one-to-one relationship. So this is going to be a primary key. And this is going to be our foreign key. But the country ID for the capital ID on the capital table, that's going to be its primary key. So its primary key is capital ID, but its foreign key is country ID. Because the connection is on the country. So that's where it's working on a one-to-one relationship. So it's more that there's a little bit more detail here embedded, which is to say that each of these would have its own, each of these tables would have its own ID as well, its own columns, right? So it's that we have that linking columns, right? As a follow-up, my question above, is the primary key often a category, an index, an ID variable? Yeah, I think most commonly it's going to be an ID or a date field, right? So the relationship between a primary key and a foreign key is the same as an independent and dependent variable. I think it's a good way to look at it. I don't think it has to have that association. I know that as researchers, where you're frequently thinking about independent and dependent variables, things aren't always, sometimes there's more complexity, and also there are things that are representing different time concept, like different concepts in the world. For example, let me show this. I think as a something that's, when we talk about the market date table, just take a look at the market date table here. It doesn't have any information about the farmer's market. It just has dates in it, right? So it has the market date, the market day, the market week, some season, the temperature, did it rain, did it snow? It doesn't have anything to do with the farmer's market until you build that relationship out to those other tables. The same thing with the postal codes. If we look at the postal codes are totally independent of the rest of the farmer's market. They're about the postal code. So ML1, it's in Scarborough. It has 35,000 people. Its median household income is 78K. Here's a million other variables I put in here from StatsCan, the number of people in retail and trade. Here's its latitude and its longitude, right? So these things can be quite independent of one another because SQL, you might have, our farmer's market is really narrow, right? We're just talking about the farmer's market. But you can think of it as you go broader than that, where you might want to have information about postal data or something like that that's completely independent of the farmer's market, but is also still connected to the farmer's market in that it's saying, oh, well, customers have a postal code. So we're connecting the postal code over to the of the customer over to the postal code data, so that we're able to then also like imbue additional analytics about the customers, right? If we have information about Alejandra, she lives in M8Y, maybe we know a whole bunch about it, Alejandra, and we're saying comparatively how what's her income compared to the average M8Y income, right? Something like that. Oh, is her median 91K or less, right? So there's different ways that you are sort of able to imbue additional analytics to that. Crystal asks, what would be an example of a primary key involving multiple columns? Crystal, will you reframe your question a little bit? Do you mean a table that has multiple primary keys?
So
Yeah.
I was reading online about the definition of a primary key since I couldn't remember.
Are you thinking about composite keys, perhaps?
I don't know. They were saying so a primary key is a column or a combination of columns in a table.
Okay, so introduction to modeling, trying to keep it simple, but it always comes up. Yes, primary keys can become composite keys, and actually our customer purchases, let me go back to the slides, is in fact a composite key. Why is that? It's because, I scrolled too far, apologies. When we talk about like our customer purchases, and the same thing actually, we'll go with let's go with vendor inventory instead. So vendor inventory, the primary key for relationship here is the market date. But the table's composite key is the market date plus the vendor ID plus the product ID, because that's actually what's truly unique for this table, because that articulates you have no duplication across a vendor and their product on a given day. So the composite key ensures that uniqueness, right? When we look at the vendor inventory table, we can see that market date repeats, but it doesn't, and actually vendor repeats, right? But the product ID is unique. So we have our market date and our vendor and our product ID, and together that's the composite key. So exactly as your question is, it's a great one. The way to truly define what is unique for a given row is its market date, its vendor ID, and its product ID, and we call that the composite key. But for simplicity, we've articulated it this way. You guys still reach that here exactly in this. The date uniquely determines the inventory for the day. That is exactly, because it's also the notion of inventory is also who and what, right? Really good question. Ellen, hand up.
Yeah, can you go back to the slide that has the product category, product, vendor, inventory, and vendor?
Yeah.
So here we have product category ID as being that one-to-many relationship, but wouldn't there only be one product category name, like for each ID? Like you don't have that repeating itself over and over again. So aren't they
Totally.
kind of redundant?
Remember the optimization component. So we have IDs for product categories. And I love your question, right? Look how simple the product category table is. 7 rows, 2 columns, super simple. But when we're talking about joining the tables, which we'll do in a query, we'll push the tables together. The join will be much faster on an integer than it will be on a text value. So product category 1, which is fresh fruits and veggies, in the product table will be all of these records. We absolutely could have just stored fresh fruits and veggies here. We don't even have to have the table if we don't want to, because it's so simple. But this is part of the conversation of database design, right? So over time, maybe it becomes more and more complex. Maybe we have some promotions associated, and then they start to phase in and out. And oh, this is active only then. And oh, actually, in 2022, we used to call it fresh fruits and veggies, but now we want to have fresh veggies and fresh fruits separately because of our promotion. And we want to archive some history because our analytics require this. Oh my God, all of a sudden, now we start to need to have a table split out because we can say, when was the date valid, right? So this was the date valid, column. And oh man, good thing you put that in its own table, because you start to imbue, maybe you have your product category and your product category, and you have some repeat, but you don't have for the date valid because they're in different spots. So exactly as you're thinking for something like that, it's so straightforward, but as things scale up, maybe they become more complex. Really, really good question. Okay, let me go back to chat here. What if there's a table with only two foreign keys and a many-to-many relationship, similar to the euro? What would the primary key? Yeah, so Noah, Noah's question is about our here. Our primary key here would be like, so member ID for the membership table is a primary key. Our country ID is a primary key for the country table. Our foreign keys are like this, but we'd also have one more, which is like our definition key or something like that. And we just don't articulate it here. But if you really wanted to make this, you would have a primary key that was like the definition or some iterative value, and it would just be counting upwards. And it would specify if you're going to have foreign keys, you're going to have a primary key in the table too. So it's just a constraining of information here. Is it wrong to think of this as a variable assignment, like 1 is Apple because 1 is easy to type? Oh, good question, Greer. I'd say it's a little bit more complex than that, but it's not totally off from that either. That was in the context here of that product category, right? So, is 1 actually fresh fruits and veggies? There's some kind of like engines below that they're exactly handling that. Okay, I think we had a good answer there on the primary key with lots of columns. If you wanted to change apple to red apple, it's easier to do just defining changing the variable. Yeah. And especially when we talk about database design, sometimes preserving history, which for an organization might matter a lot. Super good questions. Any other questions on data modeling? Did I miss anyone in chat? Good. I think we're in good shape. All right. Let's do a little bit of, we're not quite to the wrap up yet. Let's go through the last couple of slides here on the assignments. Okay, so specific to assignment 1, section 1, and assignment 2, section 1, that is related to data model. So I'm going to talk through what you need to do for each of these as they're related strictly to the data modeling concept. So for this assignment 1, section 1, the first prompt here is to meet your farmers market database. So in the assignment, you'll find that there is some instructions here on how to load your database, just like I showed earlier, just walking it through. If it's the first time, how to configure your windows, things like that. So just the beginning of this is kind of a preamble that explains how to kind of navigate the tool until you kind of get down to your question here, which is I want you to choose 2 tables and create a logical data model. Lots of tools you can do it. You can draw it by hand if that's how you like to do things. I like the Draw IO, as I said. Your logical data table needs to contain a table name, the column names, and the relationship types. So essentially what you're going to do is you're just going to remake our logical model here, but for different tables. Don't pick product, product category, product, vendor, inventory, vendor, inventory, vendor, right? Don't describe these relationships because I've already done it, right? So come back in to the farmer's market and to say like, okay, I'm going to do vendor and vendor booth assignment or booth and vendor assignment. Look through this. It will help you get familiar with the farmer's market, which is then how we're going to write all our queries. And the better you know kind of what is in each of these tables, the easier the kind of comprehension of the query design will be. So just pick 2, make your little logical model, draw out what the table name, the relationship name, the column names is. So the ways to kind of do this, use the Browse Data tab here. It's the second one. If you're on the Windows, it's a little bit more left shifted up at the top here. To figure out what those relationships types are, remember that you can't diagram tables that don't share a common column. So go back to our bigger conceptual model. Don't try to make a logical model between booth and vendor. They aren't connected. Booth and vendor booth assignments are, and vendor booth assignments are, but booth and vendor are not connected, right? And the column names, you can find them in a couple of spots. I like to use the DB schema at the bottom right, because you can open these little chevrons here for each of the each of the tables. These are our tables, by the way, and you can see what the column names are. Just make it easy. If you're doing booth, here are your 4 columns that I'm asking you to write out. And here are the 4 types. Oh, it's all right there. So that's assignment 1, section 1. There's more to assignment 1 than just the first section, but you can now start on that now that we've had our first lesson. For assignment 2, section 1, it's taking these concepts and going bigger and thinking more about the concepts broadly and not so prescriptively. I want you to create a logical model for a small bookstore. So it should contain an employee table, an order table, sales table, customer table, and book table. You don't need to populate the tables. You don't need to create data for this. You're describing the relationship, how things are built, not actually filling it full of data. So determine what columns make sense based on what you know about a bookstore or an online bookstore. Keep it simple. Just work out the relationships and keep those tables reasonably sized. I don't need 500 columns to describe your books. It's just not needed. Also include a date table. We'll get to date tables a little bit, but if you look up web search date table SQL, you'll see lots of examples of date tables. It's a great way to sort of familiarize yourself with date tables. They're very powerful SQL tools. Use Draw IO, Lucidchart again. You can't hand draw this one. I want you to use a tool for it. Just focus on the conceptual model. There's always one student that tries to like populate the data, and that would be really way too challenging. For the second prompt, take that model that you draw and duplicate it, and then add an employee shift table that will split up the day into morning and evening and connect that back to your your ERD, likely to your employee. Prompt number 3 here, the store wants to keep customer addresses, propose 2 different architectures for the customer address table, one that will retain the table and another that will override it. This is more like a written response here. Describe to me how, just describe out how these are different, which is type 1, which is type 2. Present columns, just you're making a small table. Again, you're not populating, but your column designations will determine which of the 2 architectures you're proposing. Talk about why, right? And since I'm not going to talk about type 1 and type 2, give this a search and look up, interact a little bit with documentation here on the difference between type 1 and type 2 slowly changing dimensions and how that affects your data model. So we're not including primary key and foreign key in the logical models, right? Because they're associated with the physical models, exactly right. So the logical models don't have to do the primary key, just have to do the relationships. Describe the relationship, is it 1-to-1, is it many-to-1, whatever it is, right? And the columns that are within it. So those are our data modeling related asks. Let's see, assignment 1 is due the 25th. That right? 26th. And assignment 2 is due the week after that. That's the 2nd. It's all in the repo too. Can you see what relationship type is between the table looking at the DB browser list of tables and columns? No, but you can tell based on the way the data is laid out. Just for example, the product category, we can see that the product category is a 1-to-many to the product because in the product category, we only have 1 instance of the number 1, our ID, but in the product, we have the many relationship where we have 1 repeated, right? So I hope that makes sense to that question. For the other parts of the assignments, they're about writing code and then writing a reflection to those readings. Okay, what questions do we have about anything from today? Questions about assignments, go back, anything like that? Ethan, go ahead.
Okay, so like suppose you have on like you have two different tables and then they share 2 columns or something like that. Would you have to draw a line saying like 1-to-many for each shared column?
Yeah, fortunately in the farmers market that doesn't happen. But yeah, you would in a data model, you would have to describe how that was happening. It would be hard to have a relationship, like the relationship that would be representing between the data, it would be really complicated. You probably have a table between it. Because that's like how if we go back to our kind of like our Euro tables, this almost is like a table between these 2, right? So that we're able to, this is like laid out kind of where you would go from here, and then you would go from here, right? So that's like maybe how to do that. Instead of collapsing that down, sometimes you create like a table between them, a little helper table, something like that. Again, these are like, there are practices for this and there are things that make sense kind of logically, but there isn't like a hard and fast rule on stuff. The design is really driven by the use case.
Right. Cool. Thank you.
Should the result look like the diagrams drew? Yeah, exactly. So these were made in Lucidchart before I knew about Draw.io. So they will look pretty much like this. Maybe you're some degree different, but yeah, your assignment sections will look somewhat like this and then have those explanations. And you guys are probably new to maybe new to Markdown. Markdown will support, sorry, I clicked the wrong one. Markdown will support you can write answers in here, quite literally, like there'd be space here for you to write You can attach items if you want to edit the markdown, but the learning support's super flexible. It's good to know how to do those things. I would say for you all, especially knowing how to interact with markdown, super useful thing. Try to attach your database diagrams to this. But if you're struggling with that, just make sure it's part of that commit. Yeah, hand up question.
Yeah, just going back to slide 67. No, not 67. Hold on, sorry. That would be slide 69.
I only got 64 slides.
Okay, sorry, don't worry about it. So the slide here, you have the logical model with the, yeah, no.
This one.
So the relationship you're generating, is it the relationship between tables or relationship between the columns in the tables?
Good question. It's the relationship between the tables, and it's through the columns that the relationship has defined those constraints, like the integrity constraint. So for example, remember I was talking about like you can't delete the product ID. You can't delete the product ID in the product table. We can't delete the row. So quite literally, we come in here and I was like, I want to delete this record. I wouldn't be able to because it's the primary key for product. And that has this downstream effect because every time, think about if I delete habanero peppers. When we come down to the vendor inventory for our product ID equal to 1, so for here, for example, what would it put there? It wouldn't know, like the vendor had that product. So that's where that sort of relationship is coming in between there. So the columns are sort of like the mechanism by which they're linked so that the tables have that relationship. Hope that's clear. Kelly, question?
Yeah, Thomas, I have a question. So for the assignment one, I see that section 2 and section 3 are to be done in the SQL file.
Right.
And the section 1, we're supposed to do it on Draw.io or any diagram tools, right?
Right.
And for section 1, how do we submit the diagram?
Yeah, so if you come to Draw.io and you make your diagram, sure. You can export it. Sure. So I've got my 2 squares and I can draw between them. Is that how this works? I don't know, something like that. There we go. Now you can either take a picture of this, a screenshot, you can export this. Surely somewhere there's an export. I think it's here in the file. Yeah, export as PNG, JPEG. So, okay, we have a PNG. We export that, sure. Oh, did I try to go to Google Drive? That was silly of me. Let me just download this. Okay, so I've got my Draw.io. You can do a couple of things. You can just upload this to GitHub by like quite literally in your fork coming here and like you can like drag and drop this in here.
So there's no specific folder where we should put it in.
Yeah, so see how I can drag and drop into this, guys? This is just coming from my downloads folder.
Okay.
You can come in here to your markdown. You can edit the markdown. You can drag and drop it, and you can embed it using some HTML or the markdown to embed it. Put it somewhere and say, here, my, and exactly where I'm going to put it here. So my image source is equal to, and then the path. If you're not familiar with what I'm doing here, don't stress it, right? And wherever it is. So that's an option. Then it'll just be present right there. But the learning support will be nice and flexible so long as somewhere in your assignments folder, there is a untitled diagram. Please don't call it untitled. So long as there is a diagram in here that articulates your assignment 1. Let's talk about submissions just for a second too. At the top here, there's a guide here on how to do submissions. I know you guys have just come out of your shell and get the big difference. Make your forks just as you did. Make 2 forks, assignment 1, assignment 2. Sorry, 2 branches. 1 fork, assignment 1 branch, assignment 2 branch here. And then when you go through and do your pull request, just as you've done, right? So following all this, you're making edits on your fork, not on my, not on the DSI SQL, right? Make sure you're doing it on your fork for your branch, assignment 1. Do the pull request. Since you don't have to use Visual Studio Code to do pushes, you can use other mechanisms. You can use the shell terminal to make commits. You can drag and drop in here. You see how this allows you to upload files. You can use GitHub Desktop and download the desktop UI and do your commits that way. So lots of options to commit to GitHub. The learning support will be happy to help you get it in. You're contributing to this in some way, whatever is the most comfortable for SQL. We're a little more flexible. It's great if you can do it from shell. If you're struggling from the shell, that's okay. I struggle with the GitHub stuff too. So we're all in the same boat. So good question. In the rubrics, there are your details on what is needed, and also in the assignments here are exactly what to submit. So submit this markdown. Submit 1 entity relationship diagram, preferably as a PDF, JPEG, PNG, whatever, and 1 SQL file, right? So the SQL file we'll get to, but it's here so that you can type this in, right? So good question. Thanks, Chloe. YouTubers are online resources. Cameron, I don't have any. I can think about it. Not a big YouTuber. The interrelationship between tables is established via the columns present in these tables. I'm getting clear. These columns must be here can be foreign key. I think you guys are answering those really nicely in the chat for me. Okay. Good questions. Let's see, did we hit the end of our Etherpad here? To clarify, do we need to fork the DSI SQL repo? No, sorry, Sim, that was my fault. Fork it once and then make 2 branches. So it's in the top here. Fork the main repo. Don't submit pull requests on the main repo. Here's a video guide. How many branches should I make? 2 branches, 1 for assignment 1. 1 for assignment 2. There's no auto grader or anything like that. So, you know, there's some flexibility on all of this, but this is the preferred way to do it. Good question. Sorry about my misspeaking. Okay, wrap up here. We are at the bottom of all my Etherpads here. I'll put the slides for today that we talked about. Okay, so next class, if you haven't installed DB Browser for SQLite, start on assignment 1, section 1. Let me just take the next few minutes here to just like kind of walk through. We've done it already a little bit, but let me do the open database again, just so that everyone sees. We just have a few minutes here. Let me come in just from a brand new. There's always something that people struggle with a little bit. So if you're coming into the very first time to your DB browser, probably looks a little bit like this. In your top left, here's your open database. That will open your Finder window, your file window. It looks relatively the same on Mac and Windows. Navigate to wherever you have cloned your repo. So you need to clone your repo, right? So in my documents, you guys can see like I have GitHub, right? So all of my cloned repos are here in GitHub. This is O2 Intro to SQL. And then in the 05 SRC file, there's the folder, the folder 05 SRC. There's the folder SQL. And then you'll see the farmersmarket.db. You can hit open. You won't get those OKs, but I always get those OKs. And that you'll be here You want to look at the browse data column of a window here so that you can actually look at what's in each of these. So booth table, what booths there are, customer, what customer there is, details about them, etc. So hopefully that familiarizes all of you. Spend some time with it. It's not an overly complex, and we'll get to know it a little bit more, but it's good to kind of have that. Great. Any other questions? Otherwise, we are good. 7 minutes early. That's all right. If no other questions, it's nice for me, just a little feedback here at the bottom. One thing you liked about the section, one thing that's confusing, clarification, I can write some responses to as well there. So thank you so much. I appreciate it. Nice to meet you all. And we'll see you all next Tuesday. Please reach out to Learning Support. Stick around for office hours after this with them if you want to keep talking with them.
Yeah, Thomas, I am gonna take one breakout room to specifically help people with the shell and Git. Okay, so people who have question about shell and Git, I'm going to go to breakout room 2.
Kelly, we can create 2 breakout rooms, one of them for SQL, one of them for those who have question about Git and shell. So
Yeah,
it's okay. I can create it, or if
yes,
you want-
please.
Yeah,
I'm
sure.
confused. Thank you.
Sure. I stop recording, Thomas.
Great. Thanks all. I'll stop sharing here.